Okay, in this video, we'll do a few more practice problems involving the chain rule. So one of them is, oops, oh, it's not on. What is the thirtieth derivative? What? Oh, how did that happen? Find the 30th derivative of y equals cosine of 2x. Okay. So we're going to have to take the derivative 30 times, which is going to take a long time. Or we can try to find a pattern and try to figure out what's going on and see if we can do it faster. So first, let's start by taking derivatives. So the derivative of cosine 2x is what? I'm going to use the chain rule. What's the derivative? So I see a 2x. That's a function of x. And then that's being plugged into the cosine function. So I have an outside function which is cosine of x, and then the inside function is 2 times x. So what do I get when I use the chain rule? I get negative sine of 2x times 2. Are we okay on why that is? Because the derivative of cosine is negative sine, so I get negative sine, and then I plug in the inside function, that's 2x. And then I have to multiply that by the derivative of the inside function, and the derivative of 2x is 2. And I'm going to write this as negative 2 sine 2x. Why am I doing that? Because when you're multiplying by a constant, you usually put the constant on the outside. Okay, so that's y prime. Now let's find the second derivative. What do I get when I do that? I'm going to get negative 2 times cosine of 2x times 2. Because I have a negative 2 like this times a function, when I have a constant times a function and I want to differentiate that, I can move the constant out. So I have a negative 2, that's this negative 2, and then I have to multiply by the derivative of sine of 2x. And for that, I use the chain rule again. I get cosine of 2x times 2. So, can I simplify this at all? Yes, because I have a negative 2 times 2 here. Negative 2 times 2 is negative 4. So I get negative 4 times cosine of 2x. That's the second derivative. What about the third derivative? So, for these higher derivatives, you usually put a parenthesis and a number like this for how many times you're taking the derivative. So this is the third derivative. You could use y with 3 of these marks. That's also correct. Okay, what do I get when I take the derivative? I should get 8 times sine of 2x. So let's write out all the steps. So it's negative 4, so I have a constant times a function, taking the derivative of that. So I have the constant, I can move that out, so it's negative 4. Now I have to multiply by the derivative of cosine 2x. Well, we actually did that. We get negative 2 times sine of 2x. And that's going to give us, well, negative 4 times negative 2 is positive 8, so it's 8 times sine of 2x. So let's think about the pattern. So when we did, okay, let's make a little table. So when you had y, it was cosine of 2x. Y prime was equal to negative 2 sine of 2x. Second derivative is negative 4 cosine of 2x. Third derivative is 8 sine 2x. So what's the pattern? What kind of pattern do you notice? First of all, there's kind of two things to notice. So one thing to notice is the cosine and the sine keep alternating back and forth. Now that kind of makes sense, because when you take the derivative of cosine, you get negative sine. When you take the derivative of sine, you get cosine. Okay, so when you take, when you start off with y equals cosine 2x, if you take the derivative an odd number of times, you get sine of 2x. When you take the times some constant, and then when you take the derivative an even number of times, you're going to get cosine 2x times a constant. And looking back, the question says to find the 30th derivative. So we know that we're going to get cosine of 2x times something. The question is, what's that constant? So let's try to find a pattern in the constants. Well, for y, it was 1 times cosine of 2x. Then you had -2, then -4, then 8. Let's think about where the numbers are coming from. The 1 and the 2, the 1 and the 2 and the 4 and the 8. Where are those numbers coming from? They're coming from the fact that every time we took the derivative, we used the chain rule, and then we had to multiply by 2. So what is the constant? Forget the plus or minus. Besides that, what number are we going to get when we take the 30th derivative? So when you start off with y, you get 1. First derivative, you get 2. Second derivative, you get 4. Third derivative, you get 8. So you're taking powers of 2. Because each time you're taking a derivative, you're multiplying by 2. So you're multiplying by 2 30 times when you take the 30th derivative. So if you start off with 1 and then you multiply by 2 30 times, what are you going to get? You're going to get 2 to the 30th power. Right? Because that's 2 times itself 30 times. Now we have to figure out if we have a plus or minus. So again, we have to think about, okay, what's causing the minus to show up? And what's causing the minus to turn back to a plus? Well, we see that when we take the derivative of cosine of 2x, you get a minus, because the derivative of cosine x is negative sine x. That's where that negative is coming from. But when you take the derivative of, let's use a different color. When you take the derivative of sine, you don't get an extra minus, right? Because the derivative of sine is cosine. But when you're going from cosine to sine, again, you multiply by -1, and that's why the negative turned into a plus when you get from the second to the third derivative. So now we have to think about, when you take the 30th derivative, do you end up with a plus or do you end up with a minus? It's actually kind of tricky. Let's see. Maybe we should continue the pattern with the 4th derivative. So 4th derivative, you're going to get a plus and then plus something with cosine, right? So then for the 5th derivative, you get minus. And then it's going to be minus with the sine. So then for the 6th derivative, are you going to get a plus or minus? You're going to get a minus. But then that's with a cosine. So then when you take the 7th derivative, you're going to get a plus. Okay, now I think we see what the pattern is. When you take the first derivative and second derivative, it's minus minus, then it goes plus plus, and then it goes minus minus, and then it goes plus, so this is constant. It goes, yeah, minus minus, plus plus, minus minus, plus plus. And now the question is, when you get to the 30th derivative, what do you end up with? Hmm. Well, one way I think about it is, so let's just write down the numbers for the derivative. So for the first derivative, so for 1 and 2, derivatives 1 and 2, it's minus, right? And then for derivatives 3 and 4, it's plus. Then for derivatives 5 and 6, it's minus. For derivatives 7 and 8, it's plus. So then eventually, you're going to get 29 and 30. See, every 4, it's a minus plus block. So then when you get to 29, 30, 30 is not a multiple of 4, but you have 29, 30, 31, 32, and then you're going to get a minus and a plus. So for the 30th derivative, you're going to get a negative. So you have a negative here. Okay, that was kind of tricky. I mean, the number wasn't so bad, but deciding whether you have a plus or minus is a bit tricky. You have to notice that you have a plus. Well, for y you have a plus, but then once you start taking derivatives, it's minus, minus, plus, plus, minus, minus, plus, plus. And then you have to think about when you take the 30th derivative, do you end up with a minus or a plus? But it might help to write a block like this with a 1, 2, 3, 4, and a minus plus, and then minus plus. And you see that since 30 is not a multiple of 4, you end up with a minus. Okay, and that's the answer to the problem. The answer is negative 2 to the 30th power cosine of 2x.